Good evening. I welcome you all for today's session Analysis and Design of Clocked Circuits, Finite State Machines, Moore Model. In the previous session, we discussed about Mealy model. In this session, we are going to discuss about Moore model. So let us see the difference between Moore model and Mealy model. So first of all, same I have taken an circuit here analysis of clocked sequential circuits. Here we have two gates and gate and two flip-flops that is T flip-flop. So in the previous Mealy model, I have taken D flip-flop and here I have taken T flip-flop for Moore model. So as usual, we have a primary input and primary output and two outputs of the flip-flops TA and TB, that is T flip-flop 1 and T flip-flop 2. Then input is X. From the input, we have two outputs of gate 1 and gate 2 and two outputs of flip-flops like the flip-flop 1 is A output and flip-flop 2 has B output. So before that, going to the circuit analysis, let us discuss about the difference between Mealy and Moore. So in Mealy circuit, the output is a function of both present state and input. For example, y is equal to AB into x bar means A plus B is your present state and x bar is the input. But in Mealy circuit, the output is a function of present state alone. So y is equal to AB. In Mealy circuit, both input and output were separated by flash along the directed line. But in Moore circuit, only output is mentioned along the directed lines. The output is mentioned inside the circle. And the last difference is in Mealy, output may change if the input change during the clock pulse. Hence, the output may have false, that is values because of time delay. But in Moore circuit, outputs are synchronized with clock pulse and depend on only the flip-flop outputs. So this is the differences between Moore and Mealy circuit. Now coming back to the circuit analysis of design Mealy circuit, Moore circuit, as in the first slide we had a circuit. For the same circuit, now I have written a truth table, analyzed and returned a truth table which represents the present state, input, next state and output. So your present state is A and B, your input is X and next states are A, B and Y. So present state as usual we have written in 8421 code both your present states and input in 8421 code by using the last 421 code like 0000001 010 from 0 to 9. So the next state is nothing but by using the equation, input equation and output equation, we have to derive the truth table. So your output equation is y is input equation is what else we have written there, that should be same here in truth table. So output equation is y is equal to AB. So here your inputs are 0, A is 0 and your next state A is also 0. So while you multiply A into B, you get the output equation Y. This is how I have derived the truth table of this Moore circuit. So the only difference from the truth table, we have to draw the state diagram. So this is the state diagram from the truth table. And the input, see here as we said, only the input is represented along with the directed lines and the output is represented included inside your denominator which is encircled with the inputs. So the next state 00011011 here is represented by same directed lines, but the only thing is your inputs will be along with the director lines, and your outputs will be under the denominator of your states inside the circle. So this is the main difference between your Mealy model and Moore model.